This talk will be pretty light technically. It's just a lot of storytelling, and so stop me if you have questions, and I can get into more technical details if you want. But so at a high level, I just want to talk about using secure computation to do statistics across joint data sets. So you have a bunch of data owners, and you have some analyst who wants to do some statistical computations, and you don't want to share the underlying data. And this has been proposed in the literature for a long time, and there have been various different either proof of concepts or examples using real data. And so let me talk about them a little bit. People have thought this is a great application for biology and medicine. You can do genome-wide association studies. You can look at, say, long-term health insurance trends where you have horizontally partitioned data where you have different health insurers have snapshots about different people, right? You have when I change jobs, when I change schools, right, my health insurance changes, and so their view of my long-term health trend is limited. So you'd like to sort of link those and look for long-term health trends, right? People have proposed it for financial oversight. Right, how do you look at global properties of financial networks while hiding some of the underlying the portfolios or the investment strategies? One of the projects that I was involved in was satellite conjunction analyses. You have different satellite operators, and you're worried about collisions between the two satellites. How do you compute that securely? And then related to that, a question that came up was satellites experience anomalies. So when your satellite is in space, you lose track of it for a little while. The power goes out, the connectivity goes out, the solar panel stops working or something. And the satellite operators don't want to reveal these anomalies to each other because it looks bad if you say, my satellite stopped working, I don't know why. But they would benefit from sort of sharing data. And so could you have some sort of like a global analysis tool that would allow you to pool these data? So these are the kind of applications that we're thinking about for secure computation. Most of these were sort of proof of concept kind of thing. There were a few real-world examples. The Estonian company Cybernetica has pioneered a bunch of them. They have this product ShareMind, which is a three-party BGW approach, and they've gotten buy-in from the Estonian government to do some actually statistical computations where they link data. So one of these examples was linking tax and education data. You have tax data from the tax board. You have the Ministry of Education has school district data, and you'd like to look at, say, how different education outcomes affect long-term earnings or something like this. But the cool thing here is, right, they actually got real data sets and they got buy-in to do this. And this is their little diagram of how they do it. They use a three-party computation, so no matter how many data owners you have and how many analysts you have, they secret share their data among these three cloud servers, and the three servers do a secure three-party computation. And they do the whole thing as a circuit using basically the BGW protocol, essentially. There was a really cool recent application looking at payroll statistics in Boston. I think Mayank will talk about this tomorrow. So, but there haven't been too many real like actual things where you have real buy-in from people. I guess there's the sugar beet auction from a long time ago, which I skipped over because everyone's heard that, I think. But there have been a lot more. So let me say this: there have been a lot more sort of proofs of concept than there have been successes in getting buy-in from data owners to actually do this in practice in a public way. But one question is, there are some barriers before about performance, and so just looking at this, if we're interested in doing statistics, a basic statistical tool is linear regression. And so the question is this fast enough for practical use anyway, right? If we're going to push this for practical applications, can we do this? And how big the databases can be, how much computation, how much communication do we need? There have been a lot of linear regression schemes in the crypto literature. Here are a few of them. They use all different kinds of approaches. Some use garbled circuits in combination with additively homomorphic encryption to do multiplications. There's some of them that use three-party BGW, this ShareMind application. There's actually an implementation using fully homomorphic encryption to do the whole linear regression. And so you can kind of look at these here. Actually, there are a handful more that did it maybe not as the primary application, but as secondary applications of the things they were doing. And so just pulling some numbers from these papers, you shouldn't compare these too much to each other. They're all done in different systems or something, but just to get an overall sense of what's happening, you can do linear regression on databases with millions of records in under an hour, and with thousands of records in just a few seconds, right? And this is actually, I think, pretty impressive because, right, again, these are sort of academic proof of concept works where you could probably squeeze out more performance, like the BGW row where they're doing 10,000 records. This is using a very generic protocol that's not optimized specifically for regression. They have a high-level language that they just wrote this in. And this GSV, this Gascon et al., one of the cool things there is if you look at the timing numbers, one of the things you kind of see is that the number of rows, so like the number of observations you'd have in a regression, right, doesn't affect things nearly as much as the number of columns. And that's because you can do these tricks where basically if you're using a garbled circuit approach, the garbled circuit actually will not depend on the number of rows. They'll use a separate aggregation trick, and it only depends on the number of columns. And so 200 columns is actually a lot. Like if you were in practice, if you were doing a regression with 200 variables is bigger than you'd want to do anyway. Yeah.
So how much do these approaches differ in the kind of numerical algorithm that's actually being used to compute the regression?
They're doing a handful of different things.
They're all doing different things, though.
Yeah, I mean, there's some similarities. So this Nikolenko, the NWI and the GSP are kind of similar, although the NWI is actually doing for horizontally partitioned data, so that's even sort of an easier thing. But both of them do this trick where you can break dependence on the number of rows by aggregating first, and then they do a gradient descent to invert this matrix. So basically, there's a question which is you need to do a matrix inversion somewhere. I should have. Okay, well, I got to make sure I keep moving on slides.
Maybe a more basic question
to
Adam. Are these all least squares regression?
Yeah. Well, and some of them do. There are some examples of logistic regression, and you can also do ridge regression. But for the numbers, I was just pulled out some basic numbers of this is just ordinary least squares regression. So sort of the simplest thing, just to get a sort of high-level feeling of, if somebody said, is MPC efficient enough to do regression? Yeah, these are pretty reasonable sized databases. They're not huge, but for something that social scientists care about, like this is actually pretty reasonable, yeah.
Yeah, you have a caveat, different benchmarking environments.
Yeah.
Can you say anything on what the benchmarking environments look like?
Off the top of my head, I don't remember. I mean, I think a bunch of them are just you get 2 AWS instances and you run a garbled circuit on those 2. I think some of them, I mean, they're either local networks or fast networks. They're not, and they're servers. They're not imbalanced things.
You don't know if they weren't doing it across the internet?
No, I think none of them were doing it across the internet. That's my recollection. Yeah. And yeah, just so you can actually even do it with fully homomorphic encryption using generic stuff from HElib. And right, it's much slower and smaller, but it's actually kind of surprising to me that you could even do that in a couple hours. Right, that's basically inverting a matrix under fully homomorphic encryption. So right, the point of this little story was that right, secure computation seems to be in a phase where it's actually efficient enough to do some of the computations that researchers and statisticians would want to do, but people aren't doing it that much, and part of the reason is that it's not that usable, right? These are all custom protocols that were designed by cryptographers, and they don't, for the most part, don't have much of a front end or a usability, or they're just like not easy to get in the hands of people who might actually want to use them. So I want to tell a little bit about a project that I'm working on that we just started. This is through Stealth Software, which involves a lot of crypto people who you know. And it's a joint collaboration with ICPSR, which is the Inter-University Consortium for Political Science Research. And these guys are essentially a data repository. And so one way to think about what they do is that social scientists will collect data sets that have some sensitive information. And if I'm a researcher and I collect this data set, I publish some paper. And now I have this data set that has some value maybe to other people, but I can't just publish it because I can't just publish the underlying data because it has some sensitive information, but I'd like to make it available for either transparency or so that people can do secondary analysis. So what do? I can hand it to ICPSR, and they'll act as sort of a data manager for it. And so they hold tons and tons of data sets that social scientists and other types of researchers want in all these different fields of education and aging, criminal justice, and then if people want access to these data, they act as kind of a gatekeeper, and they define some level of access. They can either say, okay, this data is not very sensitive, we'll just give it out, or they can make some kind of restrictions. They could either make you sign an NDA and then mail you a CD-ROM. They could make you go in through some sort of VPN into some virtual data environment that they control, that you're only allowed to do certain types of statistics, or for the most private stuff, they make you fly out to Michigan and go into a basement and drop off all your USB keys and use their computer, and then print out one page of paper, and when you leave, they will analyze this one page of printouts that you made to make sure that you didn't print out that's something that's identifiable to people. But they have a lot of infrastructure, they have a lot of data and a lot of infrastructure set up for sort of hand analyzing what types of security or privacy restrictions come out of data, but they also have a lot of interest in sort of collaborating with other data repositories of this type. Right? They have a lot of data, but they don't have all the data. And so this has been a nice collaboration for us as cryptographers because they have a lot of insight into sort of what statisticians want to do and what the structure of the data that they want actually is. So we just got some funding from first actually we had some workshops that were funded by the Sloan Foundation to try to bring together cryptographers and social scientists and figure out the types of the exact sort of problems they wanted. And that led to a bigger project that's funded by the Arnold Foundation, where the Arnold Foundation is interested in basically increasing transparency and accountability, and so these kind of tools can allow you to do that. You can get a lot more transparency into what people are doing, even if without requiring them to share their underlying data. So we have this project that we just started where the goal is basically to build an MPC platform to do secure statistics across joint databases. And right, there are lots of little proofs of concept, but we want something that's basically provably secure. We're cryptographers, we want it to be efficient and usable, but we also want it to be easy to deploy, right, and extensible to support a lot of different types of the applications that social scientists want to use. So let me talk about this a little bit. So just at a very high level on the technical side, most of the framework is set up to store everything as secret shares between a handful of parties. And then we do different methods for computing on the secret shares, either basically additive sharing, or if you have pre-shared triples, you can do these beaver multiplication tricks or share conversion kind of tricks. Or you can act on the shares using garbled circuits or with multiple parties with a GMW type of approach. But the main thing that's sort of different about this is, right, we're trying to make a tool that's going to be used by statisticians, not cryptographers. So you want kind of a front end, and you want to think about something like secure version of R or something where statisticians can actually interact with these databases in a sort of easy way, and we abstract and hide away basically all of the crypto side. So it's not like an MPC compiler in that sense, it would be really a high-level language for statistics. So that's the sort of goal we're working on. And we want it to be easy to deploy, right? So one of these issues is that if you have a bunch of data owners, they have to run some client. If you're going to do an MPC computation, they have to run this client. So this client has to easily interact with their databases and their workflow. So you want it to have sort of nice interaction level at that layer. So we have APIs, and right now it just can link into MySQL to pull in stuff from their databases. So the MPC client we're working with the various different data owners to try to make sure that this fits with the types of data stores that they have. We want it to be fairly extensible to support a lot of different crypto backends or a lot of different networking protocols. And so this has also been a major design feature, is trying to make sure that everything is sort of really well documented so that if you want to, as this client sort of either works with the existing network infrastructure or we want to extend it, that it's sort of easy to do. So we've sort of laid out a bunch of, at this point in the project, we've put together a sort of architecture, and we've started building some of the first use cases. And so the first use case we came out with came from Senator Ron Wyden. So how many people here know of Ron Wyden? Okay, actually more than I thought. I hadn't heard of him, but as a cryptographer, it was I was very excited to learn about the kind of stuff he's doing, right? He's really interested in pushing crypto. He wants these things that you shouldn't have backdoors in crypto, that users should be in control of their data, that the government needs to increase transparency, and so that's one of the motivating features of the Arnold Foundation, which is funding our project, is sort of how do you increase governmental transparency. He actually wrote in an open letter to the Committee on Evidence-Based Policymaking that you should actually use MPC. So there's a senator who said we should use MPC. That's, I thought was kind of cool. And he has this compact for privacy and security, which is some of the things that I was saying, is that you shouldn't backdoor encryption, and you should allow people to control their data, and you should increase transparency. And a lot of these things are things that you could address with MPC. Yeah, here's another, he wants another pro-privacy thing. So there's a little widened plug of all of the privacy stuff he wants, that you shouldn't be able to require people to give up passwords at the border. You shouldn't require people, if people let companies use their data, that's not an overall blanket acceptance that anybody can do anything with your data. But the use case that came out of this was he has this the student right to know before you go act. And so this is about education. And so as you're making college decisions, right, you want to make your college decisions based on some information. And so is this huge investment of time and money worth it? And are some colleges better, some universities better, some majors better? How should you make this decision? And he's saying right now, right, prospective students have very little information. And so a very simple kind of question that comes out of this is you could ask, say, which majors yield the highest salaries? Which universities produce the highest incomes on average? And this is actually a little bit hard to aggregate. The universities hold academic records for people, but they don't have good information about salary info later on. And so in talking with people in Wyden's office and with people at the census and various other agencies, right? So they're saying, look, you can have this application where the Social Security agency holds salary info and the universities hold academic records. And the ideal use case here is you actually have a lot of computing parties. You have a lot of universities, maybe hundreds or maybe even in the low thousands of universities, and you'd like to find really simple aggregate statistics, say, you know, means by major, something like this. And so even this kind of crosstabs application, there's some fun little crypto things of, right, how do you actually do means by category? And it depends a little bit on the underlying privacy requirements that you have here. So is a university willing to give up the list of all its students? Because then that would make, even if they're not willing to give up the majors or GPAs or something, right, the total list would make it much easier to do crosstabs, right? Otherwise, you need to do a set intersection first, and there are a lot of different set intersection protocols. And so we implemented some of these and have been doing different things. But it depends on your application. You get a lot of different scalability, basically, depending on whether you're allowed to leak some aggregate information here. And so in this setup, we have basically a statistician or an analyst and a bunch of universities and, say, the Social Security Administration. Right. So we don't have buy-in to this, but this is the actual, like, the idea. And so we're in this SemiHonest model, and so the analyst will act as a trusted dealer, can send correlated randomness, which makes a lot of the computations really efficient. And then you can do, even though you have a lot of universities, right, you would do a pairwise secure computation with the salary info. And then you get sort of secret shares of the result, and then you can aggregate these secret shares. But if you do it this way, you don't have to do a full-blown MPC with everybody. You can do just this pairwise computation, and so it doesn't scale, you know, quadratically with the number of universities. It scales basically linearly, and so it scales nicely to sort of support however many you'd want. So you'd have some application, you have an analyst, and the analyst would deal correlated randomness, and then the universities would do a pairwise secure computation with the salary info, or whatever is the end metric that you'd want. And then you could aggregate the shares. So right now, this is sort of what the architecture for this is, how we're doing it. So anyway, so this is, right now, we've just sort of gotten started on this project a few months ago, so things are progressing kind of quickly, but the goal is basically to have a really well-documented, secure sort of statistical package that would be aimed at non-cryptographers that could support a lot of different crypto backends. And in order to do this, all right, it would be basically to have APIs that essentially allow you to swap out things, but to hide that from the statisticians, right, who don't know much about secure computation. And you'd like to be able to support sort of a wide array of statistics, basically the sort of, you know, the workhorse kind of statistics that you'd want to do. And then you'd want to make it sort of, you know, efficient enough to be usable on the kind of data sets that we're talking about, which are not big data by big data standards, but they're, you know, statistical size data, so, you know, hundreds of thousands of records, kind of things like this. So anyway, let's
we've got time for a couple of questions before the break.
Yep.
Salil?
So one kind of high level, one more
specific. So high level, so I'm wondering about ICPSRs.
Yep.
Interest in MPC. So what are the settings in which they couldn't just be a trusted third party for?
So there are actually a lot of places where they don't have data. So most of the data they get, I think, are academic data sets. So researchers collect data and then they have them and they give them over. But there's, so ICPSR is based at the University of Michigan, so some of the things that they care about more are in the Michigan area. So some of the things, say, like the Michigan health system. So in these workshops that we had, one of the questions that came up, there's a lot of questions about health. So we had some people who, from the Michigan health system, the hospitals, right, they won't give any information to ICPSR. And actually, one of the fun use cases that came up from the hospitals are all worried about hospital-acquired infections. So, and so the hospitals would like aggregate statistics about that, right? How do you prevent them? What are best practices, right? But nobody will give you any information because, again, it's a question of embarrassment. And so if you could do some kind of secure computation for that, you could look at, here's the types of procedures that lead to more, hospital-acquired infections that lead to readmittance or things like this. But so medical data is a big thing. There's lots of private company data that they don't have. There's a lot of things on sort of salary data, right? Mostly for the academic kind of data sets, right? If you're a social scientist, you may collect a lot of information about people that's very personally identifiable, but you probably don't have a lot of, I guess some of them are employment, but a lot of it's not. And so then there's also even questions where they have access to, say, education data from some school districts but not others, or from some states but not others. And so there are places where they have kind of partial coverage. And so that's really their interest. And Did you had another? Yeah.
My more specific question
Yeah.
is for the use case you talked about.
Yep.
The right to know.
Yeah.
So what is the do you or the people you're working with have an idea of how you would kind of vet an analyst to decide that the SemiHonest security would suffice?
Yeah. Okay. So to be clear, this is a motivational example. Right now, no one has bought into actually deploying this. Although we would hope to. We have some demos with people coming up soon. But yeah. So how do you decide if the analyst is semi-honest? Well, so one is, on the theory side, the semi-honest is important from dealing correlated randomness, right? And so that's basically, that's coming from the software. It's not like the analyst is rolling a die. And so there you could vet the software, right? The software is all going to be open source, so you can analyze it kind of that way. In terms of whether the analyst himself is semi-honest, again, there's sort of like places like ICPSR have thought about this question a lot in terms of basically, are we going to give you access to these different data sets? And so they have some internal vetting procedure which decides whether we're going to allow you to actually play with the data that we have. And so from that side of things, there are policies in place. Like that's something that non-cryptographers have thought about a lot, basically. Like, should you be able to run the statistics you want on your data? Yeah.
Two questions. So one is, what is the blocker on getting this biased? Say,
I mean, right? It's anyway. Part of this project, there's lots of, okay. No, I mean, as you know, there's lots of blockers in general to this. We have, this project is just getting started, and so we're having our first demos, and we're hoping to have some demos on the Hill in the next month or so. And it's been really useful that the Arnold Foundation, who's the funder, has made a lot of contacts for us that as cryptographers we would not have been able to do, I think. And in particular, like Ron Wyden's office, he has, or had a Tech Congress fellow, Chris Segoyan, who actually really understands computer science and was really also a nice liaison there. But I mean, I think practically there's always a ton of issues about data owners are going to have to install some client software to interface with their database, right? And we're trying to make that as technically easy as possible by having all of the interfaces really well documented, as sort of open as possible, that all the software we make is open source. But there are going to be barriers there, but we're not even quite at the point where we've hit those barriers yet. So unfortunately, I don't have like a...
Sure.
Yeah.
So my other question, sorry, out of time. My other question was if you had given thought to the infrastructure costs. Like you talked about the Social Security Administration. They don't sound like they have a lot of infrastructure available for this.
Yeah, so like what, I mean, the infrastructure costs, like these computations aren't that crazy, and they're not, you wouldn't be running them constantly, right? So I don't think, like, I mean, right, if you have one server box running this thing that's a desktop kind of server, like that's enough to do everything you want to do. And so sure, there's some cost to that, but it doesn't seem crazy, right? We're not proposing you do it for everything. And
So this is going to be running frequently, you're saying?
yeah, basically, yeah.